Good morning, guys. By the way, my name is John Christopher Bautista from BSMT 2YA-3. Anticyclones can be identified on weather charts as an open, large area of widely spaced isobars, where pressure is higher than surrounding areas. It's worth noting that there isn't a critical pressure value that determines when we have high pressure. It simply depends on what is going on around. If the pressure is higher in one place than the places around it, then it is a high pressure area. In northern hemisphere, winds blow in a clockwise direction around an anticyclone as isobars are normally widely spaced around an anticyclone. Winds are often quite light. With an understanding of how the air moves and how clouds and rain form, how much prediction can be made by simply observing the sky overhead, observing wind direction and noting the temperature and humidity of the air. But to be able to predict and forecast weather, it is necessary to understand the isobaric patterns associated with fronts and depressions, anticyclones, and high-pressure ridges. Meteorologists plot isobaric patterns on synoptic charts. With an understanding of how the air moves and how clouds and rain form, much prediction can be made by simply observing the sky overhead, observing wind direction, and noting the temperature and humidity of the air. But to be able to predict and forecast weather, it is necessary to understand the isobaric patterns associated with fronts and depressions, anticyclones, and high-pressure ridges. The rheologists plot isobaric patterns on synoptic charts. The greater the field, the more the cloud cover measured in H or octaves. Wind direction is represented by an arrow pointing in the direction from where the wind is coming. In the figure below, the wind is from the northeast. The wind speed is denoted by feathers on the wind arrow. A short feather indicating 5 knots, a larger one 10 knots, a long and short one 15 knots, and so on.